Hello. How is everyone doing tonight? This is awesome. Thank you for joining us for the first Ruby Hour of Power. A little more than an hour, somewhere around there. We're going to spend some time together. Hi. We're going to spend some time. Hi, Lauren. We're going to spend some time together to talk about Ruby, all things awesome about Ruby. Take some Ruby questions if you have any of them, and build something cool together. We're going to build something using a pretty cool feature in the Vonage Video API called WebSockets. It just went to general release, so it's no longer in beta status, whatever that might mean to you. For us, that means that we fully vetted it. It's ready to be used. It's awesome, and we want you to use it. And there's all kinds of cool things you can do with WebSockets, and we're going to show a pretty streamlined use case of it. And we're going to do it, of course, in everyone's favorite language, the one and only in Ruby. So let's actually start doing that. I'm going to share my screen here. You should see Ruby. Yay, Lauren, Ruby, it's awesome. So you should see on your screen this guide about WebSockets on the our developer portal, developer.nextmo.com. This is a really helpful guide. In general, it talks about what WebSockets are. Essentially, a WebSocket is a way to keep a persistent connection going between two machines. So in this case, a server and a client. So instead of the response request model where you create a response, you create a request, you get a response, you create a new response, you get a new request. This is one response, one request, just one connection stream between two things persistently maintained, sharing data back and forth. So it's really great if you want to create sort of the live experience of live chat, so the chat messages can go back and forth. You often see it in that context. In Rails, there's actually a built-in helper in Rails called in Ruby on Rails called Action Cable, which is a really great set of features in Rails that you can use to sort of get up and running in the Rails magical sort of way. WebSockets made a bit simpler, but even without Action Cable and even without the help of Rails, you can do this in a pretty relatively straightforward kind of way. So the way that WebSockets work for the Voice API is it's essentially the same idea of WebSockets being a persistent connection, but in this case, the persistent connection is not, let's say, text messages. The persistent connection here would be raw audio data going back and forth. And you can have multiple participants in that audio. So you can imagine this is pretty cool. Let's say you wanted to build a conference video voice app, and you wanted to stream it online. Well, you could do that in a variety of ways, but with WebSockets, you just invite the WebSocket as one of the participants into the voice application. You connect the WebSocket, you provide it with a WebSocket URI, which is right over here. Let's make this a little bigger. Here we go. You provide the WebSocket URI right here, and that starts sending raw audio data, which you can then manipulate and share in the moment in your application, which is pretty cool. And in addition to that, you can also do, you can set the audio sample rate, the audio, sort of like the quality of the audio. Now, I'm not an audiologist. I don't know if that's the actual title of a person's job, but it sounds like it should be a title. But if it is a title and you are an audiologist and you're watching this, that's awesome. And I hope I got that right, but it sounds pretty good. Audiologist sounds like a startup. Audiologist, that's true. It could be like a great startup, like in Soho or something. So we're not audiologists, at least I'm not. But sampling rate, I had a bit of an introduction to this from one of our colleagues, a great guy who streams a lot. I would actually call be a great, really cool bar, Ben, not just a snobby bar, but a cool bar. A colleague of ours who does stream as well, Sam, and Sam was telling me about what these different things mean. So if you ever see this thing, so let me show it to you here. you see where it says here, a string representing the audio sampling rate. You've probably seen that before in your life. If you ever played with audio or done anything with audio, if you were at all like me in any sort of way, you probably just glanced over that and your eyes glazed over. And you're like, okay, that means what it means. But what it actually means, according to the source of all knowledge of humanity, Wikipedia, and according to Sam, who I believe honestly a little bit more than Wikipedia on this topic, it is the samples per second taken of an audio feed. So if you can imagine like an audio feed being kind of like a wave of data coming in, and you're trying to understand what the quality of that data is, what kind of audio you get, the more samples per second you take of that audio, the higher the quality of the audio will sound. So therefore, 40 kilohertz, right? Kilo is 1,000. 40 kilohertz would be 48 kilohertz would be 48,000 samples per second. That's a lot of samples. In this case, going back to our WebSockets voice API feature, we either offer you 16,000 kilohertz or 8,000 kilohertz. So 8,000 being 8,000 samples per second, and 16,000 being, it's a big guess, 16,000 samples per second. So that's what that means. And then those are two things you get it set. Most real-time transcription services work best with audio at 8 kilohertz, just FYI, good to know. And you can also, if you wanted to, pass in custom header data for you too. So custom header data is kind of cool because let's say you have a bunch of different WebSocket audio data you're dealing with from multiple sources coming into your WebSocket URL, and you want to differentiate which one is which. You can actually set custom header data. You could do that either statically or dynamically in your program. Let's say assign an incrementing ID to each WebSocket data that comes in, and therefore you can keep track of, well, this is audio from this, and this is audio from that, and this is audio from the other one, et cetera, et cetera. So that is really helpful for us, because what we're going to be doing, just to remind us all, remind myself much as I'm reminding you, because as you start getting to this advanced age with these gray hairs coming into your beard, you start forgetting things. And what we're doing today is we're going to build a bare bones Ruby application. So we're going to use no major framework. We're going to use some frameworks, but very light frameworks, and not Ruby on Rails. So not a lot of heft on top of it. We're going to build a Ruby application. I'm calling myself old, no one else, don't worry. A bare bones Ruby application to take in raw audio data and then to do something with it through WebSockets. So we're going to talk to the WebSockets from the Vonage Voice API, and we're going to have that data talk to our WebSocket we're going to establish as well for ourselves. That's what essentially we're doing. And what we're doing right now is just kind of sort of, we have time to schmooze a little bit. We have time to go really take some journeys together on some of this knowledge. And so what we're doing to start off with is just sort of an overview about what WebSockets are and what you can do with the Vonage WebSockets in particular. So that's a bit about that. And the rest of this guide on the developer portal essentially walks you through different parts of the data here. So for example, when it comes to binary audio messages, which is what we're going to be handling, each message will be a 20 millisecond sample of the audio from the call, right? So therefore 8 kilohertz rate, each message will be 320 bytes. This becomes important for us, and we're going to see why that's important in a little bit. But when I first started playing with this, I got a little lost in that, but nonetheless, it's actually a bit important, and you can get tripped up on this if you're not exactly careful around there. Yes, we are building a Ruby app to work with Vonage Voice API WebSockets feature. Isn't that cool? These little like, bang, what am I doing? Don't you wish, Nareen, don't you wish we had that in life? Like you could just be like, I don't know, you're at the grocery store and you're like, what do I need to get? I forgot what I was going to pick up. And you could be like, bang, what do I need to buy? And then you get something that tells you, you're here to buy more tomatoes. You're like, oh, yes, I need more tomatoes. And you go to the vegetable aisle or fruit aisle, tomatoes, whatever. You go to the produce aisle and you pick up some tomatoes. It'd be pretty cool, right? Or you're like, I don't know, in the car to go do an errand. Yes, in the car, because I live in the suburbs and we have cars here. Unlike Ben, who lives in the urban center and doesn't have a car. But so you have a car, you're driving to your local suburban center and you're like, I need to buy something. I forgot what I'm going to buy. What do I need to get? You need to buy whatever. That'd be really cool. Yeah. Bang. What's in the fridge? Bang. I need to buy something. That'd be awesome. Okay. So binary audio messages. And in addition to that, you will get through your WebSocket connection, you will get this initial JSON message. So this is not binary audio data, clearly. This is a JSON message. Yes, Lauren, I want you to build that as your next stream. You're going to build some kind of application which takes in a bang message and gives you something awesome with it. You like the shirt? You not only is the shirt great, it supports a great cause. I need to find the link, and we have time together, so I will find the link. You should definitely support the cause and the organization. It's a great shirt. And hello, Frantonio. Okay, so that's that. So let's talk about what we're going to build with. If you have any questions, by the way, about any of this, please drop them on the comments. Love questions. The answer may be, I don't know. Let's explore this together. But please, questions, comments, random topics you want to talk about. The weather outside today was lovely. It is now almost 7:15 p.m. where I live. The day is over. It was a beautiful day, lovely Thursday in this global pandemic. But we keep on trucking. Okay, so what are we going to be building with? Well, we're going to be using a few different gems, because I said it's a bare bones Ruby application, but of course we're going to use some helpers along the way. What we're not going to use is Rails, because although it is so easy, and as somebody who loves Rails, to just jump to Rails every time I want to build something, Rails is huge, right? And we don't always need it, even though it's so friendly and we are so happy with it. And we thank DHH every day for giving us Ruby on Rails. We still at times can go back to just Ruby and play with Ruby. But we do need some helpers. One of the things we need is this gem. This is called Fey WebSocket. Anyone ever heard of this gem, Fey WebSocket? As I take a drink of some fruit water, this is pineapple flavor. It's quite good. Fey WebSocket is a WebSocket implementation extracted from the Fey projects. The Fey projects in general. Let's actually open that up for a second. Right, simple messaging. You've heard of it, yeah. So it's actually kind of ubiquitous, although people don't often realize they've heard of it. So Fey is this general system that provides messaging application tooling for Ruby and for Node, which is kind of cool, right? Because why not? And so whether you built in Node.js or you built in Ruby and you've had to deal with some messaging platform, you might have used something, either Fey itself or something built on Fey. So Fey WebSocket Ruby is a gem that implements the Fey project. Did MySpace use it? Was that on there? Oh, look at that. MySpace used it. If MySpace used it, obviously it was good. I didn't even see that. And so it's it essentially allows us to implement WebSockets in our Ruby application. And you can actually use it with the whole array of Ruby web framework. So we're going to use it with this one right here, Thin, because it's what I'm working towards personally. And it's what I like to build with. So Thin is a very lightweight, as the name might give some hint to. Yeah, exactly. Oh God, Ben. Thin lets us, let me show you Thin for a second. It's basically one of the simplest, quick and up and easy sort of web server implementations you can use in Ruby. It kind of looks, if you built like with Express.js in Node land, it kind of looks like Express.js, because it's just like, I have a route and I want to do something for that route. So, you know, mywebsite.com/new. my new route will do this, and /edit will do this. And like, you just map routes to different actions. So it's very kind of like, just connect the dots essentially. So we're going to build using Fey, and let's close this. We're going to build using Fey in a Thin web framework app in Ruby. And we're also going to use Rack on top of that. And the reason why we're going to use Rack is because we need to borrow some of the Rack middleware to handle some of the data that comes in. And we're going to get to some of those details in a minute. And Rack is essentially a web server interface. And with Rack comes a whole host of really cool middleware that you can actually implement in your stack. So what is middleware? If you've heard of it, middleware is something which, so let's say you have an HTTP request coming into your web server you built, and it's before it hits your actual application level, your application layer of where it's going to do something, you can actually intercept that request in the middle, right? Middleware in the middle between the request origination and your application layer, and then manipulate it, redirect it, whatever you want to do with it before it actually hits your application. So that's kind of handy. In fact, we actually have a Rack middleware that we built for Vonage, which is kind of cool. Vonage also used to known as Nexmo, and it's Nexmo Rack, appropriately called. And Nexmo Rack does exactly that. Nexmo Rack lets you validate signatures, which are a way to verify and add an additional layer of authenticity to your messages. You can basically encrypted signatures. So you can handle that on your application layer of your application. So you get the request come in, let it go all the way through to your application layer, like to your controller or what have you, and then handle it and verify it. Or you could verify it before it even hits your application layer, like your controller, and let the application decide whether to continue passing it on to your controllers or just reject it entirely. So that's the functionality that's so far in Nexmo Rack. It does that. So you specify the signature that you want to verify it against. You specify the method. So here the example would be MD5 hash. That's your encryption method, and then you just mount it into your application. So either you could put it in here if it's just standalone Rack application, or in your Rails app, you can put it into your gem file and then just put it into your application.rb, and that's it. That's how great middleware is. You just put it there and it's there. You don't have to do anything. All the logic is already in it. It's kind of cool. So that is Rack middleware. So we're going to use Rack to get some of that Rack middleware, some of that lovely, fantastic, wonderful middleware capabilities into our application. That's essentially the tools we're going to be using for our lovely, handy dandy WebSockets voice application built on Ruby. Does that make sense? If you have any questions, again, please feel free to raise them. Questions about this, questions about this pineapple water, which is my first time trying it. It's pretty good. I wasn't expecting it to be good, but honestly, it was the only thing they had when I was taking out takeout today for lunch, and I was like, yeah, I'll try it, and it's not so bad. So, if you ever see like pineapple water in a store and you're like, should I try it? Maybe. It might not be the worst thing. So pineapple water or Ruby or Rack or WebSockets, please, if you have any questions at all. I did not have hummus for lunch today. I actually went to a place called New Delhi, which is like a sandwich shop, and I got the vegan roast beef at a deli. I don't know why I did that. I still don't know why I did that, but it was actually really good. It's like a really bad Subway, yeah, basically. But the vegan roast beef is like amazing, and trust me, I'm not a vegan, and nothing to offense to any vegans. I have many friends who are vegan, but it was quite good. Vegan roast beef, right? It was so strange. I don't know what I was thinking when I ordered it, but I'm actually kind of glad I did. It was like a surprise lunch. So if you have any question about that, please let me know. And so there's one other thing I want to touch on. One other thing I want to touch on before we start building, which is sort of the life cycle of a call. So we're going to do also, in addition to this, we're also going to make the phone call. So I want to show you, this is my phone. I have it on my computer. Isn't that cool? And so we're going to make the phone call together on this phone. So there's a bunch of lifecycle data that comes through a phone call, which is really helpful to know. And when you're trying to build voice applications, so as part of like being more empowered in sort of the call lifecycle, let's just share that with you for a minute. So if we go to, let's see here, the voice API, let's, webhook reference. Yeah, there's so many questions about vegan meat. Like, what is it? Like, is it meat? It's not meat. Like, how do we call it meat? Like, is it a capital M meat? Like, at what point does the definition of meat lose its like its existentialism? Like, is it no longer meat when it's vegan? There's so many questions. I so agree with you, Geek on Coffee. Like, what is it? It just doesn't like. I don't know. Meat has nothing to do with animals. Okay, Ben. Okay, so on the event webhook, these are all the different states your phone call can be in. So remember, this is a WebSocket voice application. So yes, the data is being sent over this continuous persistent TCP/IP connection on WebSockets, but it's still a phone call, and so it goes through a bunch of different states. So the phone calls, and you'll see this on our event data as it comes through to us. So you'll see, and I'll show that to you when we do it. So it starts with started. Some of these make sense, right? Started, the phone call is ringing, it's answered, or it's busy, or it's canceled, or it was canceled, or it was unanswered, and or was disconnected, and or was rejected, or it failed. This one's pretty interesting. I'll just tell you, it doesn't work 100%. It's still tricky. But this one, theoretically, when it's working great, will tell you whether the call was answered by a machine or it was answered by a person, which is kind of cool. I play around with it a lot. It works mostly. There are some edge cases, as there always will be. And then you get other things like timeout, completed, record, input, transfer. And this is the kind of data you'll get back as we do it. And this data comes through webhooks. All of our APIs essentially work with webhooks, which are basically, instead of asking the API, is there an update? Is there an update? Is there an update every 5 seconds? The API will tell you when there's an update. So you open up a URL path, you make it listen and available, and then the API will speak to it and let you know when there's an update, which is like kind of a reverse of the paradigm and kind of helpful. Okay, so let's start building. And remember, questions, comments about minced meat pie, pineapple fruit water, vegan meat, anything you like, feel free to ask. So let's start. So I created, let's see if I can make this a little bigger. I think that's big. I created a folder called the WebSockets Fun. And right now, if you look in the folder, there's absolutely nothing in it because we're going to start fresh. And the first thing we want to do is let's open up our code editor. There is our code editor. I like using VS Code. It's helpful. And there is nothing in there right now. So we're going to, first thing we do, because we love Ruby applications and we love working with bundler and gems, is we're going to create a gem file. It should look pretty familiar if you're not used to this before. So the gem file has a kind of standard format. The first thing it takes is a source, right? And the source is defining where it should find its gems from. And typically this will be from one place in Ruby, right? rubygems.org. Although, if you haven't seen it yet, GitHub now has the GitHub package registry. Has anyone played with the GitHub package registry yet? They have, as GitHub is a Ruby in dev shop, as it is a dev shop for many other languages, but also really big Ruby dev shop. Ruby is a first-class citizen at GitHub, which is pretty cool. The Ruby package registry, as part of the GitHub package registry, is live and well, which is pretty cool. So if you've played with it, I don't know if you play with it. What's kind of cool about the GitHub package registry is how fast it is. So we work with a lot of Ruby gems at Vonage, at Nexmo, and we sometimes iterate fast and furious on them and version increments, especially in sort of the alpha stages. And when we push up the Ruby gems, it might take 5 or 10 minutes to see the update propagate that to the point where you could then, get the version from the new version off of an application's gem file and install it. With GitHub package registry, it is propagated within seconds, which is pretty awesome. So I'll actually show you one quick example of that. Where are we? Here. Let's take rid of Wikipedia. So we actually have a gem right now that's hosted on GitHub package registry. It's aptly called Nexmo Developer. This is our platform generating tool that we built. So we took our developer platform, this, and we generalized it to become a general package registry. It was months of work to essentially do that, and it is now a gem, and it's hosted on GitHub package registry, which is kind of cool, as opposed to Ruby gems. We do plan to put on Ruby gems eventually. In fact, we'll put it on there when it reaches the 1.0 stage, which is pretty soon. But we've been using GitHub package registry to iterate fast and furious with it because of the fast response time in propagation of new versions on the package registry. So we have this Ruby gems, right? And in this Ruby gems, we want to install a few files. We're going to actually, as we mentioned, we're going to bring in Rack, which is that web framework with all the middleware that we want to use. We're going to use Thin, which is the very lightweight web server that we're going to build with. We want to include that WebSocket utility that we talked about that MySpace likes to use, apparently. And then we also want a couple other things. We're going to be dealing with JSON. And since this is not Rails, right, it's not built in, we need to include it. So we need JSON. And anything else? Oh, there was one other gem. I forgot to talk about it. One more gem. Where is it? Here it is. Wave file. It's really cool. What does wave file do? You might guess by its name. Wave file. All the gems. It's bedazzled. Lauren, we are bedazzled. Let's just admit it. We're bedazzling. All the gems. Wave file will allow us to convert all of the raw audio data coming into us, bedazzled, right? Coming into us from, it's making waves, Paul, yes. Coming into us from the WebSocket, because raw audio data, and you know what? We'll actually take a look at it together. So let's install some kind of debugger too in our applications so we can see the data as it's coming in. You can't really play that raw audio data. Yes, as my colleague Sam showed me when I had a bit of an education in this with him, you can actually import that raw audio binary into some audio application, play it. But if you're a normal human being like me and not like Sam, you might not know how to do that. And so what this does, it takes the raw audio data and converts it to a WAV file. WAV or WAV. I think it's WAV because it's WAV. I don't know. I'm going to call it WAV, and I'm going to just do that because I'm the one streaming, but that's what it is. And the gem is called Wave. So that feels like it's support for me. But the extension, of course, is WAV, which would be WAV. But it converts it to a WAV file so you can actually use it. Wave, please. Thank you. Yeah, right. I totally Papa Smurf of Death, which, by the way, great handle. It is right. Like building a Ruby application without Rails new is like kind of novel, and it's part of the reason why I'm actually doing a little bit too, because it is a little novel. There are some other great frameworks out there for Ruby. I don't know if anyone's ever played with Hanami. I think it's pronounced Hanami. Really great framework out there. Obviously Sinatra, which is a classic, but there are other ways to build Ruby apps than Rails, with all due love. And I do love Rails quite a lot. Sinatra for the win, indeed. So we're going to use this, and we'll look at the docs in a minute as we start building with it. But we're going to use this as well. So we need to install this into our application. So gem wave file, and then we said we'd do a debugger. So let's do that as well. Bug. And then let's install bundle install. Most of my time is spent on Rails 2 Geek on Coffee, by the way. And it's how I pay the bills. And I do love it too, so it's great. So you see, we have installed the gem and its their own couple dependencies, including event machine. Beautiful. We now have it. If you look in here, we see we have a gem file locked. If we inspect the gem file locked, we will indeed see that we have the gems we needed. Fantastic. We have our gems. Beautiful. Okay. What we want to do now is we want to start actually building the application. So we have a file called app.rb. Pure Rails. Pure Rails, no Ruby. I think that's like an oxymoron, Benjamin. I'm not sure what that means. You're gonna have to show me one point. Rails is a bit bloated. It is true, and it has its own issues, right? When you come to rely so much on it. So I'll give you a quick example of that. One of my favorite websites to browse and kind of lose time in is the Practical Dev, right? Dev.to, the blog, right? It's a great blog to kind of just lose your sense of like time and get lost in reading blog posts on every random geeky topic. And I recently contributed a couple blog posts on there, not in English, using non-Latin characters. And I noticed that the slug, the URL that was getting formed from the title of the blog post was not correct. And so I forked a copy of the dev code base because it's open source and looked at it and noticed that their method to create slugs was using Rails parameterize method, which is a standard Rails library method to essentially takes, a title and adds dashes to it, right? And strips it of random characters to make it a slug for a URL. But parameterize as an actual Rails method is absolutely horrendous when it comes to internationalization and non-Latin characters. And the way in which you're meant to deal with it is you're meant to actually create a translation file for every single language you want to, with key value pairs for every single language you want to have support for, which is really like not scalable. And you can imagine a website like that goes around the whole globe, like the dev, is not like a great use case for building translation files for every possible language someone might want to contribute a blog post in. So that's just an example, sort of like Rails is bloated, and when you come to depend on its built-in methods, you don't actually need to use parameterize to slug a URL, especially if all you're doing is adding dashes to the letters. You can actually just do that. Like Ruby has that. You can just replace white spaces with dashes. It's not overly complicated. But when you come to rely on the Rails methods, you end up kind of losing also some of the beautiful support that Ruby has built in for internationalization. Or Ruby was built in and originated not in an English-speaking country, right? Originated in Japan. But that's all to say, yes, when you rely on Rails too much, we kind of lose sight of some of just what we're trying to do. Bonjour, David 909090. Okay. So we're going to create an app.rb, which is going to house the logic for our application. And then we also want to, I know, but they don't handle it better. I also want to create one view. So I'm going to create a folder called views, and I'm going to put a file in there. I'm going to call it index.html.erb. I think that's all I want here. I'm pretty sure. Yes, I think that's it. Okay. So I have an app.rb and I have an index file. The app.rb is essentially where everything's going to be, all the logic of the application is going to be housed. And then the index is going to be the one view we're going to have for the application to play our audio back to us. It's not going to be a heavy front-end application because I'm not such a front-end dev, but it will have some front-end, a little HTML, not so much CSS, despite my t-shirt. Okay, so that's done. If there's any questions, again, I like to just mention as we go through, please ask them in the chat, or any comments about this or anything else, whether WebSockets, building in Ruby, voice applications, manipulating audio. The answer very well may be, I have no idea, but let's learn this together, or we'll look it up later. Or if you want to ask other random questions about vegan meat or pineapple flavored water, you're welcome to ask that as well. And we'll all be bedazzled together in our Ruby building. Okay, so the first thing we want to do in this application is require everything that we installed. So we're going to require rack, we're going to require thin, we're going to require a WebSocket, we're going to require WAV file, require JSON. Am I missing something? Oh, we want to also require ERB, which is part of rack middleware, to handle this .erb, right? The ERB is embedded Ruby in HTML. And then we also want to include rack, and we're going to include WAV file. Beautiful. Okay, so we've included everything. Does that essentially make sense? I think that makes sense. And now we want to start building. So the way we mentioned that we build with a thin web server is kind of like Express.js, where you match routes to actions, and the actions are, you can either define them as methods outside and then invoke the method in the action, or build the logic inside of it. We are going to build it inside of it because we're going to be relatively lightweight in our coding tonight. We're just going to get something up and running to show the use case of it. Use obviously better ways to modularize this and to really make your code really cleanly architected, but that is not going to be our goal tonight. Our goal is to show how cool WebSockets are and have fun with them. So we can do this with map statements, but we actually need to wrap this all in a rack app. So this is going to be it's going to look a little complex, but we're going to break it down after we build it. So rack handler, so rack namespace handler, namespace thin, right? .run. And this is one of the beautiful things about Ruby is like, it is how it reads, right? So yeah, there's some special syntax in there, but we're running something, right? Okay, run. And this is going to take an argument of rack builder, right? And this, we're going to instantiate an instance of that. And this is going to take a block. So there we have our block. And we're going to say inside there that we're going to use Fay WebSocket. Yep. Dot load adapter. And what adapter are we using for Fay? Because remember, Fay can work with a variety of web frameworks. We are going to be using thin, as we mentioned. And we also, you want to do one more thing in here, and this is where the rack middleware comes in handy, is we also, again, Ruby, right? It's just use. Like, how beautiful is that language? It's like, it's English, right? So use rack static. And we'll talk about what that is. We'll break this all down in a minute because there is a bunch of stuff happening in here. Use rack static URLs, and this is an array of strings. I'm only one string in here. Recording. And the root is recording. I think that is it. Yep. Okay. That's it. And then the rest of the application actually will be inside this block. So if you have any questions on that, please ask them. But let's actually break it down together. So we invoke .run method on the namespace rack handler thin. And if it sounds as it is, it's from the rack interface. It's in the handler class, so handling different web frameworks, and then specifically which one, thin, right? So now we're saying we basically saying we want to use rack in the context of the thin web framework. We want to run it. What do we want to run? We want to run a new instance of a rack application. And we need to also use Fay WebSocket to intercept the data, right? And we want to actually understand WebSockets are not native to Rack, so we need to incorporate the WebSocket utility from Fay WebSocket. And similarly, like thin.run, WebSocket has a class method called load adapter, which takes an argument of a string representing the framework that you're using. Did I say? Oh, you're right. Yeah, not recoding. Although we could recode, but I think recording would probably be better. And then this part here, so this was my first time actually doing this in Rack as well when I first started playing around with this. And that's when I learned about this beautiful Rack middleware called Rack Static, which lets you serve static URLs, because we're going to serve a static WAV file. And we're going to actually assign that to the URL of recording and the root of recording, which is kind of cool. Let's see if we can find some documentation on that briefly. Yeah, here we go. So the rack static middleware intercepts requests for static files, JavaScript files, images, style sheets, and the etc. here for us to be audio, based on the URL prefixes or route mappings passing the options, and serves them using a rack files object. This allows a rack stack to serve both static and dynamic content. So, and then they provide some great examples. You can make it a lot more complex than we need it to be. But there's a lot of examples here as well in the documentation. Okay, so that's that. Any comments there while I take another bit of pineapple water? I'm running low on the pineapple water. I don't know what I'm going to do after. Benjamin, can you bring me some more water, please? You can take a taxi. It's okay. You can expense it. Okay. So that's that. And now we're actually going to build some of the data mappings. So the first one we want to map is the route to the WebSocket connection. Exactly. Okay. Map cable. So this is going to be the route that we're going to tell. Remember, in the WebSocket reference guide, very American. I'm incredibly American geek on coffee. It was over here. Guides, WebSockets. Please, Benjamin, I would like a Fuji water. Can you bring it over now? I'm sure you can expense that. You provide, no, just Fuji water is fine. Just one. I'm sure it's fine. You provide a URL for the WebSocket, right? And there's the base domain, and then there's a slash whatever. So in this case, we're going to use /cable as the path, and this is going to be a block, a long form block, so not in curly brackets, but with a do and an end, and it's going to basically tell it what to do. And this we're going to use Fey WebSockets. So we say run. Passing in the environment. So the environment is all the sorts of information that comes back from a request to our rack web server. So that means like the data type, whether it's HTML or JSON. It means the URL. It means the query parameters. It means everything. It's a huge amount of data. But we're going to pass in that data and then give it curly brackets. And then we need to actually put in some conditionals here. So the conditionals we're going to put is first an if statement. So if Fey WebSocket, what do you think that does? If Fey WebSocket, but it needs an argument, environment. So if the WebSocket is in fact a WebSocket, meaning if this data coming in to this route of /cable is actually what we think it is. So then let's actually do something with it. And what we're going to do with it is we are going to assign it. We're going to create a new instance of the class and assign it a variable. And then also let's put this out to the console. So connection open. So we are going to create an instance of the Fey WebSocket class, assign it to this variable WS, and we're also going to let ourselves know in our console that we have a WebSocket. Kind of cool. And then we also are going to do one more thing. We're going to instantiate an instance variable called call data, and we're going to create it as an empty array. And you'll see what we're going to do with it momentarily. That's the first things we do. So now we have a WebSocket instance available to us, wrapped inside this if statement that if it is in fact a WebSocket connection that was that hit this URL, then let's create it. And then if you look at the WebSocket documentation, you see, let's find it. You see that we have all these methods. WebSocket, and it takes on, right? The method name is on with an argument of a symbol. So on open, on message, on error, on close. And then we can send back, send message, ping message, etc. So in this case, what we're going to do is say WebSocket on message. So when we get a message from the WebSocket, which is either going to be one of two things in the Vonage WebSockets API. It's either a voice API using the WebSockets feature. It's either going to be that first message, which is to let us know it was connected, and that's going to be JSON text, or it's going to be binary audio data. And the binary audio data comes to us in the form of an array of binary data. So we need to understand which one it is, because if it is the JSON event message as a string, or as JSON, we don't actually want to send that and convert it to audio because that is in fact not audio. But if it is the audio, then we want to use it. So that is what we need to do at this point. So we take the event. So now we have the message, we create a do block, and we assign it a temporary variable name of event. And if the event.data is a what? If it's an array, if the event.data is an array, then we know it is what? We know that data is the WebSocket raw audio data. So then remember this variable we created, we're going to take that data and we're going to actually include it into that array, that empty array we created. And we're going to use the append method, which adds the data to the array, event.data. So if it is event.data is an array, we know it's the raw audio data because it can either be the JSON text or it can be an array. It's one of two things. Else, it's not that, then it's going to be the initial message that it was connected. So we can just put it to the console that let us know the WebSocket was connected. Does this all make sense so far? Is this pretty clear? So if the Fey WebSocket if this connection is in fact a WebSocket connection on this route, then we're going to open up a WebSocket instance. And we are going to take the data that comes in and we're going to check whether it's an array or not. If it is an array of data, we know it's our raw audio data. And therefore, we're going to append it to this instance variable of an empty array that we created with the data from the event. And if not, we're going to put it out, and that data will be something like, as we said over here, something like this. WebSocket connected, the content type, etc. Cool, right? Pretty straightforward at this point. So we end that, and we end that. And then we need to also make sure to handle when this WebSocket is closed. There's some stuff we got to do as well. So WebSocket is closed, another do block. What do we want to do? We want to let people know WebSocket connection is closed. Sad face. I don't know why. Why not a sad face? And then what we're going to do is, now that we have, when the WebSocket connection is closed, that means the transmission of the audio over that persistent data connection is done. And if it is done, then we can then create the audio file. We have a full audio file. Now, there's a few things you could have done here. You could have streamed the audio as it was coming in, but that actually is a bit complex to do in a simple Ruby Rack app to convert the audio as it's happening. I think the easiest way we could probably do that is have a bit of a lag. So like how like live TV in the States, I don't know if it does in other countries as well. I don't watch live TV here, but like live TV in the States has a few second delay between the actual live video feed and it hitting your TV. So you could kind of have that as well. Like you could buffer a few X amount of seconds of audio data, convert it to a wave format, and then play it out. And so it'd be like a few second lag. Or we could do what we're going to do here, which is collect all of the audio data. Once it's done, convert that to a wave file and then make that available to play. The bleeper delay. Is that what it's called? The bleeper delay? It probably is called that. It makes sense. The bleeper delay. So let's say we are building a very cautious, very conservative bleeper delay. And we're going to do this. And this is how I kind of create stuff. Is I first create the method before I actually create the code for the method. I reach out to the method and identify it in my head conceptually and place it where I want it to be placed, and then I build it after. It helps me like sort of construct the flow of the application that way. Other people would build out all the components first and then put them together. I first put them together and then build the components. It's sort of just how it works for me. So the method we want to create is, we're going to call it create wave file, right? And it's going to take in the call data of the audio data, right? And it's going to take the call data, and one thing we need to do is flatten the data, because what happens is this appends an array of data to an array that we created, and so we have an array of arrays, but we want to actually just flatten that data and make it at one flat array, which is a way of saying it's mono audio, meaning it's one audio. If it's stereo audio, it's a bit more complicated, and it's beyond my pay grade. So we're going to keep to mono audio, if that makes sense. And then we also want to pass it a path for where to store that audio. So recording, not recoding. Thank you, Papa Smith the Deaf, for catching the last typo. Recording dot wave. That's basically it, I think. That's it. So we have that. I think that's it for this part. So if you look here, we have the cable route. WebSocket is a WebSocket. Put WebSocket connection as open. Create an empty array. Open the WebSocket connection on the message. Check if it's an array. If it's an array, assign it to the call data. If it's not, put the event data out, because that'll be just the JSON data of the connection was opened. And then on closing, create the WAV file. I think that's basically it. Okay. Now we've done that. We can map the next route. Sound good? Yes. Sounds good to me. So it's good to you. Okay. So the next route we want to map is, I think, yes, that looks good. This is closing that. Perfect. This is closing that. I don't want to close that though. Okay. Okay. So, okay. Map. The next map. This is going to be the index route. And here we are essentially going to serve the data. So we are going to check if the file exists. If it exists, we're going to pass an instance variable to the view. And that's it. And then we're going to run. So the same as before, we pass in the environment, and then it takes an array with different options. This is the HTTP status code we're sending back. 200 essentially says it's okay, serve something, it's all good. And then the content type. Oh, the content type is actually, nope. That. I believe that's correct, right? We're setting HTML. Yeah, is it application HTML or text? I always forget. I think it's application HTML or text HTML. Content type application. I think it's application HTML. Text HTML. I always forget that because application JSON, application HTML, it makes sense in my head, but in this case, it's actually text HTML. And then we also need to pass in what we're actually be serving, and that comes in as a form of an array. We're going to be serving an ERB file, and this is actually going to be a method. We're going to create the method as well. Views index.html.rb, because unlike Rails, we don't have the ability to just automatically parse embedded Ruby. So we need to actually create a bit of a small method to take the Ruby and embedded Ruby and the ERB and parse it. Where were we? We were down here. I think that is it for that. Any questions? All make sense? It's a few last routes we need to create before we can run this. One is webhooks answer, and one is webhooks event. So we mentioned how the API, the way it works is through a webhooks data. Webhooks data, as we mentioned, is sort of like the instead of you asking your friend every 5 seconds if they have an update for you, like how the test go, 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 the friend can get back to you and say the test went great, I got the job, or the test went great, I graduated. They can tell you and let you know when the update happens. So webhooks is essentially that model, but we need to create a couple paths for those webhooks to be able to give us that data. And one is the answer data that says the call has happened. So the answer data is what we do with the call when it comes in, and we answer that by either providing a URL for the Vonage API, Voice API, to then reach to that URL and get instructions on what to do when the call comes in, or we provide inline to that route the instructions we want to give. And the instructions are in the form of a JSON object. We're going to do it inline. Those instructions, by the way, are called Nexmo call control objects, or NCCOs, but really they're ultimately just key value pairs in a JSON object. And the second route is this route right here on line 52, webhook/event, which is, we had shown a few minutes ago, the different call states that a call could happen in. And so that will just be where we get that call state data as it comes through the life cycle of the call. We don't need to do anything with it in this instance, but you can imagine that you can act on all those call states as they occur and do different things in the application logic of your application, depending on the call state. For us, what we just want to do with it is basically acknowledge that it happened, let the API know we received the data, because that's another point as well with webhooks. Going back to the friend scenario who wants to give you an update on the test for that job, they're a very eager friend. So if you don't tell them you heard them, they're going to keep on saying, did you hear me? Did you hear me? Did you hear me? Can you hear me now? Wasn't there like a phone company that had like commercials like, can you hear me now? Can you hear me now? So that kind of model. So you have to let your friend know that you heard them, and you let them know by sending back HTTP call status of acknowledged. So that's at the very least what we're going to do, is just acknowledge the fact that this call occurred, that the event data came in occurred. Verizon, indeed, that was what it was. Okay, so those are the two routes we need to do. The important route is actually this answer route. This one first to acknowledge. So let's actually build the acknowledge route first. That we acknowledge the data came in, and we thank the API for giving us the data. So like all the other ones, it has the same syntax or environment, and we're going to pass in too many spaces, 200, the same format, content type, text, any text, why not HTML? But instead, we're not giving anything back to the API. So we are just going to return, and everything this is always in an array. So we're just going to return an empty string, because that doesn't really matter. So that's the webhook event. This is where it was a really critical route. This is where we're going to supply the instructions to the API to what to do when a call comes in. And this instruction is what tells the API to establish a WebSocket connection. So same as like the other one, environment. Okay, and then this is the NCCO. So remember, an NCCO stands for Nexmo Call Control Object. It itself is an array of objects. And each object is an action, specific action that you want to do. The actions are run consecutively. They're not run together. So one finishes, the next one starts. There are ways to make some of them asynchronous, but by default, they are synchronous. They run consecutively. So the first one we're going to tell to do is to say something. This is important. It's utterly like kind of cosmetic, meaning it doesn't actually do anything about the WebSocket connection. It doesn't actually create the connection, but it's important to let somebody who calls you, like let them know that the call was answered. Otherwise, it's just a silence on the other line, the sound of silence, which is a great song, but we can also play that song back to them, but we're just going to say something instead. You are being recorded. You're being recorded. Please start speaking. Sounds good, right? And then the next object is going to be the actual WebSocket connection. That's using connect. So as you can see, each action defines sort of what you want to do, and then those actions, those discrete actions, take parameters. So the connect action takes a parameter of endpoint. And itself is an array of objects. There's a lot of arrays, a lot of objects here. You can kind of get lost in them if you don't space them appropriately. That's why I think spacing of them is so important. Type, WebSocket, which then takes a URI. Now, this is really important. This URI, this URL, this URI needs to be externally accessible to Vonage Voice API. If it's not externally accessible and it's just like local, if you put in localhost 3000/cable, localhost 3000 on port 3000 doesn't actually exist in the real world. It only exists on your local environment. Benjamin, they do let you know. You just it's in the fine print when you come in. You signed it away, unfortunately. So we actually have to provide this as something that can be reached. A great tool for using when you're developing locally to make an externally accessible URL is Ngrok. So we actually have a tutorial on Ngrok, and I always search for it because I remember the URL, which is tool/Ngrok. It's a very complicated URL. And this actually talks about how to set up Ngrok and how to use it with our APIs. Once you have it up and running, it becomes really like a life-saving tool for developing locally because it lets you like talk to external APIs and the external APIs that talk to you without having to push your code up to like AWS or Heroku or anything else. You can just do it all on your computer on your local environment, which is kind of cool. Although, fair warning, if you have a lot of connections coming in, it does like eat up your CPU processing power. So I was at, where was I? I think I was at RailsConf last year in Minneapolis. I think it was Minneapolis. And I was showing off a lightning talk of playing the game of Telephone in Rails. I made a Rails adaptation of the game of Telephone, the kids game. And I said after the lightning talk that the game is available to play with for the next 10 minutes. And I let my server stay open and I provided the phone number and it was running on Ngrok, right? So it was externally available. And my computer, my MacBook started heating up. It went crazy. There were like hundreds of connections coming in for that very short period of time. So be warned, a lot of connections can make your computer not happy. So we need to actually provide a URI here. I actually use the same URL for Ngrok often, not all the time, but often, which is my name, .ngrok.io. It's easy for me to remember that way because remember, gray hairs in the beard. I need to remember these things. And the last thing we need to provide here is a content type. And this is the audio content type, not like text HTML or application HTML and application JSON, but what kind of audio we want to pass in. So if we go back to, I forgot the exact specification, but if we go back to the guide, we can copy and paste it. WebSockets. There it is. That's what we want to use. It was audio something. Okay. Great. Audio /L16 rate 16,000. Do you know any resources for finding how to better scale Ruby, specifically in Rails? You know, Rails actually is pretty scalable. It just needs the right resources, which is kind of a catch-22. But if you provision the right resources for it, like for example, in the right what are they called? I'm blanking on the name, but the right amount of resources in Heroku, for example, or in AWS, the right amount of resources, it can actually work pretty well. And look, you know, GitHub runs on Rails, so that's kind of cool. And GitHub gets a lot of traction, where it gets a lot of traffic on a day-to-day basis. It is scalable, but it's not so scalable on one's personal MacBook at a conference when hundreds of people are making connections to that MacBook. Lo and behold. So we have our action, talk, text, you're being recorded. Please start speaking. And then the second consecutive action of connect to the WebSocket. That all looks good. Oh, I almost forgot. We need to pass this as JSON. Remember we made available up here the JSON thing, the JSON gem, also known as a thing. So we need to actually use it to JSON, right? And then we also need to do the same thing we did before, which is the standard rack sort of syntax for how to serve this data. So we say it's a 200 HTTP status code. Again, content type. And this time it's application JSON. And the content is the NCCO. And the NCCO being the variable we named it. I don't think that's it. Yep, that's it. So we have, I think this is essentially what we need. The only thing we're missing at this point, down here, we actually need to provide a port this application can run on. Let's say port 9292. Doesn't really matter. Okay. Now we need to actually build those methods. So we talked about the create wave file method, and we talked about down here, where was it? The ERB method to serve this ERB file. So let's actually create those methods. So we're going to go back up here outside of the block and create those methods. Create wave file. It's going to take in data, and the file name is the arguments. And we also want to create an ERB. What were the arguments we said would take? Takes only one argument, right? Yeah, just the template. Okay, so we have two blank methods. I missed Ben's answer, but if he didn't mention asking Ariel from Cloudinary at the Israel RB, then he answered incorrectly. Wait, Benjamin, what are you talking about? You have to give more context. Ariel is one of our friends who works at Cloudinary, which is a image manipulation company that works with image APIs and video APIs, which lets you transform image data on the fly, either using webhooks or making calls to the SDKs that they have. They're also a Ruby shop. Locally in Israel, they are one of the biggest Ruby shops in the country. So they come up a lot in Ruby contexts. And Benjamin and I recently created Israel RB, which is a reinvented Israel Ruby meetup in the country. But I don't remember exactly what he's mentioning here, Benjamin. You got to give me more context. Who answered incorrectly? Probably not me. Or me. It might have been me. Okay, so create wave file. Let's start with there. So let's look at the API docs for a create wave file. So we're going to look at the wave file gem. We need to use resource for scaling in Rails. Oh, yeah, that's true. You can ask Benjamin for more details later. We're going to use two things in here. We're going to use buffer. Buffer represents a collection of samples in certain format, and specifically buffer, we're going to instantiate a new instance of buffer. And then basically we're passing in the data, the raw data to this buffer, and then we're going to write that data. So we're going to use this, and you see it takes in arguments of samples and format, an array of samples. If the format has one channel, which is mono data, mono audio, which is what we're playing with, this should be a flat array of samples. And this is what it kind of looks like: 0.5, 0.4, negative 0.3, etc. And then, and it also takes in the format. And the format for us is actually going to be PCM16. So if we look at the docs again, messages that are binary represent the audio of the call. The audio codec presently supported on the WebSocket interface is linear PCM 16-bit with either 8 kilohertz or 16 kilohertz sample rate. So if we go back to the WAV file, PCM 16-bit. So linear PCM audio with 16-bit. And 16-bit means all the audio integers range between negative 32,768 and positive 32,767. So that's what we need to use. And the second thing we need to use is the writer class, because the writer class is what we actually write the audio data to a WAV file. So it takes in the file name and the format. A little less complicated. Okay. So in this thing, we're going to say buffer equals buffer.new, and the data that we passed in, and the format is going to be, we need to also use the format class from the gem and instantiate an instance of it. It's mono, meaning it's a flat array. It's PCM 16, so it's the PCM 16 kilohertz and 16,000 sample rate. So now we have a buffer. And then we need to create a writer. So writer.new takes an argument of the name of the file, which is what we pass into the argument to the method we're creating. And again, format.new, and I believe it's the exact same. PCM 16,000. I believe that's correct. Right? Yes. And then writer, now we have a writer instance, writer.write with the buffer. And then when we're done, writer.close. I think that's roughly it. And then we want to end by passing the method will return the name of the file again to us. There's probably better ways of doing this. This is just a pretty quickly, easy way to get up and running with it. So we take in the data, writer, That's pretty good. Does that make sense so far? I think there's one thing I'm missing. I'm just checking. Give me a second here. Makes sense to you, Lauren? That's so happy. It makes me happy. That's good. Oh, I knew I was missing something. So there is something that caught me for a while, and when I was first playing with this a week or so ago. So if we go back here to remember the raw audio data that's coming in, and it's in the event.data format, right? The raw audio data is being intercepted by Fey WebSocket. This is really important, and it wasn't obvious to me. The raw audio data as it's being intercepted by Fey WebSocket audio. So if we search binary, look at this. Make this really big. So raw audio, so data either comes in as a string if it's text for text frames, or an array of bite-sized integers for binary frames. What does bite-sized integers mean to you? And I actually asked that question on Twitter because I was thrown off by it, and I saw that 2 out of every 10 people were equally thrown off by it. Bite-sized integers, in this case, means exactly 1 byte. The audio is coming into us as 16 bit, which is 2 byte. So it's actually coming in double the size, and the WebSocket handler is breaking it out and halving it, which if you would just pass that directly to the audio creation of the WAV file, you're going to end up with a really garbled audio. And it took me a long time to figure this out. So what we actually need to do is convert this back into the original format that we get it from the Vonage API from. And we're very, very thankful that there is an actual built-in Ruby standard library methods to do this with. Bite-sized integers seem like it varies based on how large developer's mouth is. Well, Michael, for you, it might be different. For me, it might be different. We're not going to get into those sorts of details on this stream. What's your favorite store-bought hummus? The answer, Michael Jolly, is none. There is no good store-bought hummus. There is good restaurant hummus. There's good homemade hummus, but there is no good store-bought hummus. And the only good hummus is classic hummus. None of this added flavors that you find in Trader Joe's and the like. So the method we're going to use in the Ruby standard library is pack. Pack and also unpack, by the way. So let's just load this. You did touch a nerve. So packs the contents of an array into a binary sequence according to the directives in a template string. This is like a lot of data that goes way over my head, but we essentially need to do something with it, and we'll just make this really big so we can see it. So you see some examples here. I don't know what all this means. It's a lot of audio. stuff, which is complex, and I'm sure Michael Jolly can explain it to all of us later. But we need to essentially take the data, which is 8-bit signed, because that's what it is to us. It's 8-bit data. That's what Fey WebSocket turned it into. And we need to turn it back into 16-bit data. So C, right, 8-bit signed, and S is, where's the little S? Somewhere over here. S is essentially 16-bit. There it is. See right under it. 16-bit signed. So we turn the 8-bit data back to 16-bit signed data, and we can use and instead of like specifying do this for every bit that comes in, we can use a key symbol of an asterisk to say do this for all the data on both ends. This is a lot of audio knowledge, but essentially this lets us get the data back in a way which can be recognizable. And that's because of the way that the WebSocket handler intercepts the data and kind of messes with it. So pack, so we're going to pack it from the 8-bit audio, and we're going to unpack it. So we get 8-bit binary data. We're packing it as signed 8-bit audio data, and we're unpacking it after we do that as 16-bit. Why do we need 16-bit? Because that's actual human speech. 8-bit, you can't hear yourself, or you can hear yourself if you listen really closely. It's not very audible. But 16-bit, 16 kilohertz is much more audio, is much more audible. So I forgot that before. That's incredibly important. Okay, so we have that method. The last method we need to do is just to create the ability to handle the ERB index file we're going to create. So the path is expand path, taking in a template as the template, right? And then erb.new, and we create a new ERB context by reading the path, and then result, and we bind it. I think it's binding, right? Yes, I was right. Beautiful. Okay, so we have all that. We have everything here. I think we're good. I think we can actually run this. We ready to run it? I think we're ready to run it. You feeling ready? I'm feeling ready. Okay, so the first thing we need to do is start up Ngrok. And what's really cool about Ngrok, by the way, is you see this web interface link here. So if we would actually copy that and go to the website, what we'll see it, but as requests come in, they'll come up in here and we can actually watch them, which is pretty neat, if I do say so myself. And then we need to run our web server. So let's actually terminal, there you are. Fin. Oh, I already see. There it's already for me. Beautiful. Okay. So start, and we pass in the name of the server file, app.rb, and the port of 9292. I have a syntax error, as we are, or ought to have. Two-way file. Did I not close it? Where was it? It's up here. Create WAV file. Do. Am I missing something here? What am I missing? Let's take a look. Unexpected keyword. Do blog on line 10. WAV file data file name. Do. I think that looks good. What am I missing? Oh, wait. Just a method, not a do. That's what I was missing. Okay. Now what am I missing? 25. Am I not closing something here? URLs. That looks good to me. Not closing something. Let's just look again. Oh, comma. Not load Fey WebSocket. Did I type it correctly? I think I typed it correctly. Oh, different syntax. Live debugging, my friends. There we go. Beautiful. Yay, it's up. Okay, let's call it. You are being recorded. Please start speaking. Hello, we are speaking and we are live on Twitch, and that is so awesome. And it hung up on us, which tells me something didn't exactly go right. Let's take a look at the event data. So we see that it started. That was the inbound call. Then we see it was ringing. Then we see we answered, which is great. And we passed in. This is what we sent back to the API. That looks good. And then we see it was answered. Get cable. It didn't seem like it. It should say here that the data type changed to WebSocket. So it looks like it's trying to handle it as HTML. That might be our actual problem. Unanswered. Interesting. Completed. Let's take a look at our code again. And you see here, you see it, by the way, as it's happening over there, which is kind of cool. Let's take a look at our code again. ERB template. Okay, we got Fade WebSocket load adapter thin. Cable. Did we pass in the right URL to the WebSocket? Yes, we did. What are we missing? Oh, you know what? I think we need to actually say it's a rack response. So before we get to the over here, is it over here? No, on close. Over here. I think we need to mention that it's actually sending back a rack response. I believe that's part of it. Let's see what happens. Okay, let's call again. Internal server error. What's our internal server error? What's the internal server error? Oh, look, there's some error message here. That's helpful. We love error messages, my friends. I'm going to find local error method WS. Am I in the wrong place? I'm in the wrong place. That's why. Aha. I should be up here. So on close. On close that method, and then over here, let's try that. You are being recorded. Please start speaking. I am speaking. Is this recording? No, the call ended too fast. Let's see what happened. Let's just take a quick peek. No, see, it didn't. Oh, I also didn't create the route, but 1 second. Let's just take another peek here. Oh, see, we have also internal. Well, that was before. Okay. So got our WebSocket connection opened. And assign that. We create an instance of the WebSocket on message. If it's an array, do this, which is great. Else puts the event data. We also are not seeing the event data, which is telling us that we're not actually connecting correctly. So let's see what's going on. So event data, and then on the close, create wave file, rack response, end. Let's try and figure this out. Oh, wait, are we closing the method? 1 second. Did we close this method? No, we didn't. And are we closing to maybe it's an extra end? No. Maybe we should. Right? Those ends, Lauren, it's always there. I'm glad you had rice pilaf. Was it rice pilaf, Benjamin? Okay, let's just walk through this line by line. Okay. What are we missing? Rack thin. Maybe we don't need to require the thin. We are debugging live, my friends. This is awesome. If you see something, let me know.
You are being recorded. Please start speaking.
We are speaking. Is this working? We'll find out. No, it's not, because we saw it hung up. And we didn't see any connections being sent. We do see the request to the cable, which is cool. Okay, let's see here. Create wave file. Got that. We got that. ERB. Rack handler thin run. Rack builder new. Fay WebSocket load adapter. Thin use rack static URLs recording root recording. Map cable do. Run environment if. And this if. Let's see here. If second environment puts call data, WebSocket, FaceSocket, new environment. And then on a message, if the event data is an array, we append it, we pack it, we unpack it, and end, two ends, and then a close, we end, and then that. Wait. We end that. We end that. We end that. It doesn't look like we're closing. I think I'm right? We're not closing this. We're not closing. map. So why is that telling me? Oh, no. Oh, you know what? Maybe that's the problem. That was the problem, I think. I think that was the problem. Right? We didn't close the map. Let's see what happens.
You are being recorded. Please start speaking.
We are speaking. And look, the WebSocket connection is open. We did it. We figured out that end statement. How beautiful is that? We're now going to stop talking. We're getting there. Okay. Thank you, Lauren. I appreciate the support. Line 44. Called oh, that's an easy one. That caught me. Remember, we called our variable to hold the empty array call underscore data, and I had called dot data. Doesn't help. But if we look over here, see that in the Ngrok data report, you see that it says it gets, as opposed before, it acted like it was HTML. Here it's telling us it's switching protocols to WebSocket data, which means we are very much in the right path. So let's actually do this one more time. I think we might have reached it. I'll bring over since I brought this, I might as well do that and call it. We are speaking, and we see that it says the audio connection, the WebSocket connection is open. Hopefully this means good things. Let's see what happens when I hit disconnect. No such file directory recording.wave. Another thing, my friends, this is coding live. Flatten, create wave file. File name. Oh, let's actually create a directory. See what that does. Okay. Here we go again. Ready, everyone? Let's try it.
You are being recorded. Please start speaking.
We are speaking. Hopefully this will create a file. We will find out. This is very, very exciting. 1 hour and 35 minutes into this adventure together. There's the file. Yay! I feel excited. You should feel excited. WebSocket connection is closed. These why these little puts to the console messages are helpful. So we opened it, we closed it, and we have an audio file right here to play, which is beautiful. Now let's just create an index view so we can actually look at that audio file. So listen to that audio file probably more accurately. So we go into the index file, and it's being pretty lightweight audio file, a lightweight view, HTML. HTML. We're going to close every tag. Head. You said I don't write a lot of HTML, so I don't have like auto close for me. Okay, title, Ruby WebSockets on Twitch. Title. Okay. Body. Vonage WebSockets plus Ruby plus Twitch equals, and remember this little Unicode hearts. Yay. Tag, and then create a div, because why not? We should probably do that. And let's actually do that. Close that div before we start working with it. And then Remember, we created a file, and we put the file name into a file, into an instance variable called file. So we're actually going to wrap this in an if statement. So if that file exists, we're going to do something with it. What are we going to do with it? We're going to create a little bit of an audio tag. I think that's how you do it. Audio controls, source is going to be recording / file name using ERB here. If I can type ERB. File name, that looks good, right? There we go. That's the audio source. And then I think we got to close the audio source. That looks good. Okay, close the audio source and div body HTML. Great, right? Everyone, that looks good? Okay, let's go to that website. Showing let's make one more audio call. So this all in sync.
You are being recorded. Please start speaking.
We are being recorded. Benjamin is listening. So this is very important. It must happen exactly right. Because not only is Benjamin here, but so is Lauren. This is really important, my friends. Where's the audio file? Where are you, audio file? Recording file. We passed you as a variable, right? If we go back over here, if file exists, oh, file exists. Recording. Let's try this again. Wait. Let's do this. Remember bybug? Wait, why are you not? Why are you not? Huh. Let's try this. Okay. Do we not load? Oh, do we not require bybug? We didn't require bybug. Yes, we're in it. Okay. Does the file exist? What do we think it should say? It should say true. It is true. So the file, file equals, maybe it's that. Because does the file exist? False. But in our HTML, we said the audio was recording / recording.wave, right? We said that. What am I missing? I'm missing something simple here, probably. Audio source. Recording file. I mean, obviously, this is what it is. Obviously. What am I missing, my friends? I'm missing something. Something simple here. File recording.wave. Audio tag, if the file, there is a file. Let's put a bybug in there. Exit. Yep. Let's exit. Let's take the bybug out of here. Let's try Try this again. No source file available for ERB. File. File is a thing. No source file available for ERB. That's interesting. We require ERB. Require ERB. We have an ERB file. Are we in the right place? We're obviously serving that ERB file because we see it. We see it. URL is recording. URLs is recording. Root is recording. Not missing something in there. What are we missing now? Recording.wave. The ERB method says take a template. ERB.new. Gallery path dot result. What happens if we try that? We're probably in the still in here, that's why. Oh. That looks like audio controls source recording /wave recording.wave. It actually looks okay, right? That looks okay also. We're missing something. The audio tag ERB is there, right? It's there. What are we missing? We are missing something. Audio controls, audio source. Oh, how'd that happen? Where'd that come from? Where'd that come from? Now there's an audio player. That's so strange. Isn't that strange? You all saw it wasn't there, right? You saw it wasn't there. I wasn't making that up. It wasn't there. And now it's there. That's really strange. But it's not playing anything. But it's there. So let's just try calling and see what happens.
You are being recorded. Please start speaking.
We are speaking again. We are recording. Here we go. Okay, the audio player is there, but it's grayed out. If we look at that audio player, can you see this? Should I make this bigger? Audio controls, source, recording / record, unable to play media. That's interesting. Well, there it is. I'll play it to my speaker so you can hear it. Again, we are recording. Here we go. We are speaking again. We are recording. Here we go. Did you hear that? You heard it. We are speaking again. We are recording. Here we go. That was our audio from that was our audio from the WebSocket audio connection that basically ran through the WebSocket persistent data connection as raw binary data, and then was sent to the WAV file gem to convert to a WAV file, and then played. And that was the audio quality we essentially get back, which is pretty nice. And if you, I don't know why it didn't pop up in the HTML. I don't know. HTML constantly confounds me. It's there somewhere. I don't exactly know why. I did remember the Unicode for a heart, which is kind of cool. I don't know why the audio wasn't there though, but it's there. If you want to see what the audio actually looks like as a data file, so let's just take that for one quick second and close with that. So if you, let's see here. Let's put a bybug in here just to see what it looks like. If you're ever curious about what that actually looks like. So let's close this for a second. Let's start up the app. And we're going to call. And what's going to happen is it's going to stop in this method. It's going to stop in, oh, I forgot to put in there. It's going to stop in this method. We can look and inspect the data for a second. We are inspecting the data. I want to see what it looks like. Okay, and now if we look at data, what it looks like, that's raw audio data. I don't know exactly how that raw audio data becomes sound. Some of you might know that. I have no idea, but that actually becomes data at some point. It becomes an audio file that you can listen to at some point, I mean. And you see the range of numbers. You see some positive numbers, positive integers, a lot of negative integers, and a pretty big range. And the range should be from negative 32.768 to positive 32.767 in that audio. So all of that, which is housed in a single array, which represents mono data, mono audio, gets converted to a WAV file. That basically wraps up our adventures in our first Ruby hour of power. Hope that was fun for you, especially the live debugging and watching us figure out where the end statement went, which was great and awesome. This was great. Yay. Thank you, everyone. I hope you have a wonderful night, and it was a pleasure being with all of you. The debugging was your favorite part, Lauren? I am so glad. That's live coding, right? It's just debugging. I mean, you write code for 5 minutes and debug for 3 hours. Isn't that typically how it happens? That's essentially how it happens. I think so. Thank you very much, my friends.